Good evening, everyone. We are going to see some problems in laws of motion. Okay. So in the laws of motion, particularly, we are going to see some problems in law of conservation of momentum and Newton's second law of motion, which says that the rate of change of momentum is equal to force, or the impulse is equal to change of momentum. So using this concept, we are going to see some problems. So in this laws of motion chapter, as we discussed in the class, basics and fundamentals, we are going to see some numericals in laws of conservation of momentum. Okay, so in this first problem, as you can see, a ball weighing 10 power minus 2 kg, okay, hits a hard surface at a 60 degree with the speed of 5 meter per second and rebounds with 3 meter per second. The ball remains in contact with the surface for 0.01 seconds. The force exerted by the surface on the wall is. So here it's like this. So this ball is hitting this surface, that is this hot surface. Okay, let us take this as this hot surface. It's a hot surface. This ball, which is weighing 10 power minus 2 kg, okay, it is hitting this wall, okay, the surface, and it is rebounding. So rebounding, it's bouncing back. It's like this at an angle of 60 degree with the vertical, with the wall, okay, with the vertical line, I can say. So this is the path of the ball. It is hitting here and it is bouncing, rebounding here. Okay. So while coming down, that is while it is hitting this wall, it is coming with the velocity of 5 meter per second given the problem, and it rebounds back with the velocity of 3 meter per second. So the velocity here, its component, okay, will be equal to cos 60, v1 cos 60 and v2 cos 60. Okay. So here what they are asking, the ball is in contact with the surface for 0.01 second. When it is in this contact, what is the force exerted by the surface on ball? So what is the force is exerted by the surface on the wall? How much force is transferred? Okay, how much force is given by the surface on the wall here? Okay, so we are going to use this force will be equal to change of momentum by time. Okay, this what is change of momentum? Final momentum minus initial momentum by time. What is final momentum formula? Momentum is mass into velocity. Okay, final momentum is mass into final velocity minus mass into initial velocity. That is where initial momentum here. Okay, that's where initial momentum, and divided by t. So this will give you the force value. Okay, here mass is given, initial final value, final velocity is also given, and the initial velocity is also given, but these velocities are not hitting straight, okay, on the wall. So they are hitting the wall or the hard surface at an angle. So this velocities vector will have two components like this. Okay, so this is this while it is hitting, this ball will have two components. So along this x-axis and along this y-axis. Okay, so this inclined vector, it's an inclined vector, so it will have two components. In the same way, while rebounding back in this direction, that vector also will have two components. Okay, so this vector which is rebounding back will have two components. So along this x-axis, and the y-axis will be upwards. Y-axis will be upwards. So these two vectors, while hitting and rebounding, will be in the opposite direction. So this one is a initial vector. So initial vector coming down, so it is b minus p y I take. Okay, p y I. So initial momentum. Okay, initial momentum vector, and what is rebounding back. Okay, it is upward direction. So I take a final momentum. So p y f. So this is a final momentum. This is your initial momentum. Okay, so this is here along x-axis you have the same direction. So px initial momentum, and this one is px Okay, Px final momentum. Okay, rewrite it again. So it will be Px final momentum. So here both are in the same direction, and also it is tangential to the surface, so it will not create any force here. This momentum uh, will not change any, create any force here. But these two forces, okay, vertically, they will create some force that will, okay, they'll transfer some forces to the ball, and the ball will be giving some reaction force in the opposite direction. Okay, so the delta P along, we are going to see the delta P along y-axis alone. Okay, delta P along y-axis, delta Py. So there will be momentum final along y-axis minus momentum initial. Okay, will be momentum initial along y-axis. Will be momentum initial along y-axis divided by time. Okay, so you know mass into velocity. So I take this mass as common value. What is the final velocity here? Final velocity is what? This one v2 cos 60. The v2 is 3 into cos 60 minus, okay, and this one is initial velocity is downward, so I take this as minus of velocity is 5 meter per second and cos 60. Okay, so this will come to mass is also given here. So mass is what? 10 power minus 2 kg. Okay, mass into velocity, that is change in velocity. The change in velocity, this is 3 into cos 60 is 1 by 2, minus into minus will be plus, 5 into cos 60 again, it is 1 by 2. So this will become 10 power minus 2. We take half is a common factor, we will get 3 plus 5. Okay, 3 plus 5, so it will become 8. So it will be 10 power minus 2 into 8 by 2. That will become 4 into 10 power minus 2. So this is your delta Py, that is change in momentum in y-axis. We are going to find out the force exerted. The force will be equal to delta Py by t. So it will be 4 into 10 power minus 2 divided by the time. The time is here, given the how much time it is contact with the surface, it will be 0.01 second. So 0.01. So this one I can write as 4 into 10 power minus 2 divided by 1 by 100. This 1 by 100 I can write as 4 into 10 power minus 2 divided by 10 power minus 2. 1 by 100 I can write as 10 power minus 2. So this 10 power minus 2, 10 power minus 2 get cancelled, you will get 4 Newton. So the force exerted by the ball or by the hot surface on the ball will be 4 Newton. Based on the option, you can select it. Okay, if you have any doubt in this problem, you can mark and come, we can discuss in the classes. Okay. Okay. So coming to this next question. Liquid of density rho flows along a horizontal pipe of uniform area of cross section A with the velocity v through a right angle bend. What force should be applied to the bend to hold it in equilibrium? See, there's a pipe like this. Okay, this pipe, it is some liquid is flowing through this. Okay, some liquid is flowing through this pipe in this directions. Okay, with some velocity v, and because this velocity of liquid is there, so it is a not a straight pipe, it is a bent pipe. So when the liquid flows is here, it will create some force here. When the liquid flows in this direction, it will create some force here, and because of this, the pipe will tend to move in this direction. The pipe will tend to move in this direction because it is changing its direction here. So the pipe will move in this direction. So I have to give some force here in this direction, okay, in the opposite direction to hold it. So that I have to clamp it. So they are asking what is the amount of force I have to give. I have to force how much amount of force or clamping force for this pipe, so that to hold the pipe in position, to hold this pipe in position. See, for this I have to find out the how much force this liquid is creating on this surface or inner surface of the pipe. So for this, what are the data given? That is, we know this density of the liquid is flowing here. How much density of the liquid? What is the density of the liquid? Okay, based on the liquid, the density will change. So the density of the liquid is rho, and what is the velocity? And also area of cross section of the pipe. That is A is also given. Okay, so when we can find out the momentum change. Okay, the momentum changes. So the momentum changes in along x-axis and also in y-axis. See how much momentum is there in along x-axis and the y-axis. So we know momentum of any mass or any liquid also. I can take a mass into velocity. Okay, that is P. P will be equal to m into V. Okay, assume that some small mass, some delta m, is flowing in this direction for some time t, delta t. Okay, it is flowing for some delta t here. Okay, or we can say it is some small volume, so delta t, and this small volume of delta v. Okay, for this mass, to calculate that, we know density is equal to what? Mass by volume. So I'm taking it as delta m by delta v, capital V. So that is where a small volume, okay, from here to here, some volume of liquid is flowing. Okay, and this delta v I can write as delta m divided by, because area of cross section is given. Okay, area of cross section is given, so A into delta L I can write. This volume I can write as cross section area into for a small length. So this small length delta L, I can take how much liquid is flowing for the small length. So area into length will give you volume. Area into length will give you volume here. So delta M by A into delta L. So this implies I want only the mass here to calculate the momentum. So delta M will be equal to what? This rho into A into delta L. Rho into A into delta L. Okay. Now I have to find out the momentum. Okay, momentum along x-axis. Momentum along x-axis and y-axis. So momentum along x-axis Px will be equal to mass of the liquid into change in velocity. Change in velocity, final velocity minus initial velocity. That is where momentum. And if you want to find out the force along x-axis, will be the rate of change of momentum. So will become Px by T here. Okay. The same way for Py will be m into v minus u by, and that will be f into y will be equal to Py by T. Okay. So this is your change in momentum. Okay. So I want to find out the resultant momentum here. So resultant, because it is changing from x to y, the resultant momentum will be the same formula for resultant vectors. Okay, but both are vectors only. So the resultant momentum will be your, say I can say it is P. Okay, so you can take it as P here. Momentum resultant P will be equal to, I can take this mass constant. Take this mass constant. So the change in velocity here, in final velocity or initial velocity 0, so that I can say is v and v here. Okay, so they will become mv the whole square plus mv the whole square root of, because the angle is 90, I can use the Pythagoras theorem. So here in this direction, what the momentum? mv. Okay, so like this x direction, what is the momentum of liquid? mv. What is the direction in this? What is the momentum along this y-axis? That also will be mv, because it's flowing the same velocity here. So but only the direction changes. So the resultant will be mv square mv whole square, like that. Okay, so that's your change in, that's your momentum, resultant momentum. So it become, I can take this m square v square plus m square v square. Okay, that will become 2m square v square 2m square v square root of become root 2 m into v. So this is a resultant momentum. Resultant momentum will be root 2 into v. So this one velocity is given. This mass you are having it as a mass flow rate. Okay, that is mass flow rate is dm by dt into v. This mass, see mass, this is delta m. Okay, will be equal to I can write as rho a delta l. This one I can write as root 2 this dm. Okay, root 2 into rho into a into delta l by dt into v. So this delta l by dt, this l by t is nothing but your again your velocity. It will become root of 2 rho into a into v into v. So this one I can write as root 2 into rho into a into v square. So this is the force developed. This is the amount of force developed on the pipe. Okay, this is the amount of force developed on the pipe while the pipe is turning 90 degrees. Okay, if the pipe is turning with some other angle, okay, the 45 degrees, some 60 degrees, the force will be different. Okay, force will be different. So here it is 90 degrees, it is changing. So I have to apply a force exactly at 45 degree in opposite direction. So because it will bend, it will push the pipe in this direction. So I have to apply force in the opposite direction. So the amount of force will be based on how much density of the liquid is flowing, what is the cross section of the pipe, with what velocity is flowing. The velocity is more, area of cross section is more, and the density of the pipe is also more, then the more force will be exerted on the pipe. Okay. The next question. A shell following a parabolic path explodes at its highest point in two fragments somewhere in its flight due to some internal forces. The center of mass of the fragments will move inward. Okay. So here a shell following a parabolic path. Okay. So here this is the x-axis. See, this is the y-axis, and this is the x-axis. Okay. So at some angle, one shell is thrown this direction. Some shell is thrown with some initial velocity u. Okay, with some initial velocity u. The angle with respect to the horizontal will be theta. So when I am throwing like this, it will follow this path. This shell will follow this path. Okay, we follow this path like this. And at the highest point, what they are saying, at the highest point, it explodes. Explodes means it splits or it okay, it cuts. Okay, explodes into two fragments. Okay, so this ball uh, into cut into two like this. So this mass is m1 and this mass is m2. So total mass is m1 plus m2. Okay, the center of mass of the franks will move in. Okay, what will the center of mass of this fragment will move in what direction? Okay, the center of mass of fragments will move which direction they're asking. Okay, so here also, apply this law of conservation of momentum. Law of conservation of momentum here. The thing is, when the shell explodes at the highest point, okay, this is the highest point h max. Okay, and this is the range. This is the range. How much this called as a projectile motion. This is a parabolic path. How much distance is that travel along x-axis? Okay. So at this highest point, what is happening? This the shell which has been throwing here at this highest point is breaks into two. Okay, it explodes into two. Okay, based on it had after exploding. Okay, it had number of chances. Both can move in the same direction, or one fragment can go up and one fragment can come down. So we don't know. See, this two masses. See, I'm having one mass here. This explodes into two means See, this may be same value. This mass and this mass can be exploded into exactly half. They are saying the two fragments. That means two pieces. So the two pieces, maybe this one may be bigger, this may be smaller, or both can be equal. This may be much more. This one is much more bigger. This one is much more smaller, like that. So different combination. So, but if I add it, I'll get this mass. Okay, if I get the mass of this shell. While it is after explosion, this bigger mass can go up, a smaller mass can come down, or both will can travel. So different options are there for that's what the final velocity of the first mass and the final velocity of second mass v1 and v2. It may be changing, but that both the masses initial velocity is u cos theta, because along this x-axis you have u cos theta. This is the angle. Okay, so vertical axis will be u sin theta. Okay. So that will be changing according to the height. So it is when the shell is moving up, it will be slow down, and while it's coming down, its acceleration will increase. Okay, its velocity will increase while coming down. While it's going up, it will become slower and slower, and maximum height, the velocity of the shell will become 0. After that, it starts coming down in this direction. Okay, this is what happened here. So here, when we are considering about the mass at the highest point, after that it is exploding. See, at this highest point the u sin theta is 0. At the highest point the u sin theta will be 0, because maximum height, the velocity, vertical height will be 0, vertical velocity will be 0, only the horizontal velocity will be there. So that fragments initial velocity will be m1 plus m2 into u cos theta along x-axis, so it will be I. Okay, that will be equal to the final velocity. Final velocity is what? Final velocity of first fragment. First bigger mass may be m1 v1 plus m2 v2. So this is the final velocity of two fragments here. So based on this, which direction they are moving, okay, which direction they are moving, I can find out the velocity of v1 or v2. Their ratio will be given. Okay, we'll be solving this problem. This type of problems, this model given some numericals will be solving. Okay. So here you have to understand that based on the explosion, the fragments may go in different direction. One bigger mass may go up, and the smaller mass can go down, come down, or both can move the same horizontal direction, whatever. Okay. So based on this, the velocity direction will change. Okay. Based on this, the velocity direction will change. Okay. A bomb moving with the velocity. Okay. A bomb moving with the velocity 40I plus 50J minus 25K. Okay, this is a bomb which is moving with this velocity, and it explodes into two pieces. Okay, of mass 1:4. It means I'm having a mass of bomb that is 5m. Okay, this one explodes into two pieces, that is 1 and 2, and this one is 1m, this one is 4m. So this mass explodes into two pieces. This bomb, okay, this bomb explodes into two pieces after explosion. This is moving with the velocity what? It is moving with the velocity of 40I plus 50J minus 25K. Okay, and it explodes into two pieces. After explosion, smaller piece moves, so this smaller piece moves with the velocity of 200J plus 70J plus 15K. And they are asking what is the velocity of the bigger mass. Okay, what is the velocity of bigger mass? So here we can use a law of conservation of momentum before explosion and after explosion. What is the velocity of the bomb before explosion? It is moving with the velocity of this one. So what is the bomb mass? You know, momentum. Okay, before collision and after collision. Okay, the change in momentum or the system's momentum before collision and after collision are equal. Okay, so here before collision, the bomb is moving with the 5m mass with the velocity of 40i plus 50j minus 25k. This is the momentum of bomb, okay, before collision. And what is the momentum of the bomb after collision? Will be, it is exploding into two pieces. So 1m into v plus 4m into v. This 1m into v, this velocity is given in the problem. Okay, so this one can be written as 5m into 40i 50j minus 25k is equal to 1 into mass of small mass, that is m. It explodes, or at explosion of this fragment, okay, that small mass is given in the problem, that be 200i plus 70j plus 15k, okay, plus 4m into v. This v only we have to find out. This v only we have to find out. They are asking the velocity of the larger piece. So larger piece is 4m, because this bomb, this is 5 mm, it is exploded into two masses, 1m and 4m, 4 times mass, 1 time mass. So here I can cancel out this, all this masses here. So this equation I can cancel this. Okay, so this 5 into 40 will be equal to 200i plus 5 into 50 will be 250j minus 25 into 5 will be 125k. That will be equal to 200i plus 70j plus 15k plus 4v. We have to find out this v only. Okay, so here this 200i and this 200i will get cancelled up, and 250j minus 70j will become 180, will become 180j, and this minus 125 plus 15 minus 125, this plus 15, when it comes this side it will become minus 15. Okay, so minus 15 minus 125 will be 145k. Okay, so this will be equal to 4v, and this implies I can easily find out the value of v here. So the v will be the velocity of, what is the v? The velocity of the larger piece, that is 4m mass. Velocity of the 4m mass, the bigger mass velocity, will be equal to 180j minus 140k divided by 4. So from this 180 by 4, 180 by 4 is say 45j minus 140 by 4. Okay, 140 by 4 is 35. Okay, that will be 35k. So this is the velocity of and velocity direction of the bigger mass. Okay, larger piece. This magnitude also I can find out by what is the velocity of this velocity magnitude will be 45 square plus 35 square. If I take the square root, I can get the magnitude of this velocity in meter per second. Okay, so in the vector form I can write, as per the option, it is 45j minus 35k here with 35k. Go to the next problem. Okay, so the next problem, a shell is fired from a cannon with the velocity of v meter per second. Okay, at an angle of theta with the horizontal direction. At the highest point in its path, it explodes into three pieces of equal mass. One of the piece falls down vertically while the other traces its path to the cannon. What is the speed of the third piece? So assume this is the cannon here. Okay, this is the cannon, and it is one shell. Okay, and this one shell is being with respect to horizontal. Okay, with respect to this is horizontal. Okay, so this angle is theta. With this they are uh, one shell is fired. Okay, it is fired here, and it is assumed that it is reaching here. Okay, reaching this point. So this is the maximum height, and this maximum height, this velocity of this shell will be in this direction. There will be mass of the shell is m into velocity into cos theta. Okay, this is the velocity here. It explodes into three pieces now. So initially it is mass is say 3m. Okay, its mass is 3m, and it is uh, exploded into three equal pieces. Okay, or if I take m, it is explodes into m by 3. Like that. Okay, so this one is exploded into m by 3. This is m by 3. This is m by 3, and this one is m by 3. See, after exploding into three pieces like this, three pieces, after reaching here the maximum point, one of the mass reaches the same path, so it is coming back to the same path here. So it will be minus m by 3 v cos theta, m by 3 v cos theta, and one of the mass is coming down. Okay, so will be m by 3 into velocity. Maybe if I take it is coming down, say some velocity, sin theta or some value, okay, along this axis vertically. Okay, and they are asking what is the velocity of the third piece. This is the third piece. Okay, this one I'm taking as velocity as v1, that is m by 3 into v1. What is the velocity of this one? So v1 we have to find out. Okay, by the conservation of mass, the first mass, say it is retracing the path, I'm taking it as minus m by 3 into v cos theta. Second mass is horizontal component is 0. Okay, horizontal component for the second mass is 0, plus for the third mass it is v1 m by 3, v1 into m by 3, that will be equal to, at this point what is the momentum of the mass will be mv cos theta, mv cos theta. Okay, so from this I can say this one minus m by 3 v cos theta plus 0 plus v1 m by 3 will be equal to this one, so, mv cos theta, and this equation I can cancel this mass and this mass and this mass. So what I get finally here will be minus v cos theta by 3 plus v1 by 3 equal to v cos theta. So this implies v1 by 3 equal to v cos theta plus v cos theta by 3. Okay, you take the LCM as 3 and you will get 3v cos theta plus v cos theta is v1 by 3. Okay, this 3 and this 3 you can cancel it, so this implies v1 equal to 4v cos theta. So that is the velocity of the third fragment. This will be the velocity of the third fragment. So 4v cos theta. Okay, go to the next problem. Okay, so here we have a bomb of this is 1 kg. Okay, this is 1 kg thrown vertically upward. So it has been thrown vertically upward with the speed of 100 meters per second. After 5 seconds, it explodes into two parts. So here, say this is the ground. Okay, then thrown upwards. They thrown upwards with the speed, initial speed of 100 meter per second. Okay, so it has been traveling for 5 seconds. It's going up. Okay, the g will be minus g because against acceleration due to gravity, it is thrown up. So minus g. After 5 seconds, it explodes into two parts. So this bomb explodes into two parts. One part is 400 grams. So this one is 400 grams, and the other part is automatically 600 grams. Okay, this will be 0.6 kilogram and this will be 0.4 kilograms. There are two masses. Okay, it has been exploded. This one part 400 gram comes back with the speed 25. So it is coming back. This 400 gram is coming back with the speed. What the speed now? 25 meter per second. It is coming back with the speed of 25 meter per second. What is the speed of the other part just exploded? So what is the speed of the 600 mass? They are asking. What is the speed of the 600 mass? Okay, we can use the law of conservation of momentum. Okay. So this mass, that is bomb, it is in the height. Okay, it's some reaching some height vertically upwards when it's thrown upwards. So what is the velocity here of this mass? Will be v is equal to u minus gt, because it is thrown up. So you have to find out the velocity there. So initial velocity, it is 10 minus g is 10. It has been traveling for 5 seconds. So this will become 100 minus 50. So it will be 50 meter per second. So at this height, the velocity of this bomb is 50. So what is the momentum of the ball? Initial momentum of the ball before explosion. So mass of bomb into velocity. That's the initial momentum. So initial momentum is mass is 1 kg, 1 into 50. So that is a p value, that will be 50 kg meter per second. So this one is exploded into 2. So this 50 is exploded into 2 pieces. So one is 400 grams. That means 400 grams mass into its velocity is given. It is 25 plus second one is 0.6 grams into its velocity only we have to find out. Say it is v. So from this we can find out the speed of the other mass, that is 600 grams. Okay. So it will become 50 will be equal to 0.4 into 25. How much it is? 0.4. 0.4 is 1 by 4. Okay. It is a point. Okay. This 0.4. 0.4 I can write it as 4 by 10 into 25 plus 0.6 into v. Okay. So this will become 50 equal to 25 into 4, 100. 100 by 10 is 10 here. Okay. So here this bomb is coming back. Okay, the one part is coming back, so that that final momentum will be here, will be minus here. Okay, so 10 plus 0.6 into v. So this will become 60 is equal to 0.6 v. So v will be equal to 60 by 0.6. That will become 100 meter per second. Okay, that will be upwards. Okay, it will be upwards. The velocity of this 600 gram mass from this bomb will be 100 meter per second. Okay, we'll go to the next question. So coming back to this question, a boy of mass 60 kg is standing over a platform of mass 40 kg placed over a smooth horizontal surface. He throws the stone of mass 1 kg with velocity of v equal to 10 meter per second at an angle of 45 degree with respect to the ground. Find the displacement of the platform with the boy on the horizontal surface with the stand when the stone lands on the ground. See here, the arrangement is like this. See, there's a platform here. Okay, this platform weight is 40 kg and it is placed on a smooth surface. Okay, horizontal surface. Smooth means there is no friction here, so it is very smooth, so it can move forward and backward very easily. On this a boy is standing. Okay, his mass is 60 kg. His mass is 60 kg and he is holding one stone and this mass is 1 kg and he is throwing this. Okay, he is throwing this with respect to the horizontal. Say it is 45 degree. Okay, with the initial velocity, what is throwing now? It is 10 meter per second. So it is like a projectile motion. So this is the range here, and this is a height here. Okay, this is the time taken is time of flight, and when he throws this ball from here to here, what the time will be, how much time it takes. That formula you know, that is 2u sine theta by g. Okay, so here I can use this law of conservation of momentum. When the boy throws the ball in this direction at an angle of 45 degree, and because this is standing on a platform, and this will move in this direction, the platform will move in the opposite direction. Okay, this platform will be moving in the opposite direction, and it will have some displacement. Okay, so find the displacement of this platform. That's the question asked. Okay, find the displacement of the platform with the boy on the horizontal surface when the stone lands on the ground. When the stone lands on the ground, so it will take some time. So till the time this platform will be moving, so till the time how much distance it has covered. Okay, as for the laws of conservation of this momentum, the momentum of ball will be 1 into v cos theta in the horizontal direction. Okay, it will be in the horizontal direction. So the horizontal velocity, that is v into cos theta. The cos theta is given the problem itself. What is that? 45 degree. So v cos 45 degree, that will be v cos 45 degree will be equal to the change in momentum of the platform with the boy. So 60 plus 40 into v. Okay, this v is also given in the problem. Okay, that is 1 into 10 into cos 45 is root 2. 1 by root 2 will be equal to 100 v. Okay, and this can be cancelled. So 10 v. So this v will be equal to 1 by 10 root 2. This is a v value. That is the velocity of this platform moving back. So this is the velocity of the platform moving back. So it is moving, while it is moving with this velocity, it will cover some distance. To how much time it is moving? So that is the time will be given by this formula. That is time of this flight of the stone will be equal to 2 into initial velocity of the stone, that is 10 divided by sine 45. Sine 45 is also 1 by root 2 divided by g is 10, and this get cancelled. You will get 2 divided by root 2. This is equal to root 2 seconds. Okay, so time of flight. So displacement s will be equal to what? Velocity into time. So velocity only we have found out. So velocity is 1 by 10 root 2. Okay, 1 by 10 root 2 into time. Into time is root 2. Into time will be root 2. So here this root 2 will cancel. You will get 1 by 10 will be 0.1 meter. So this platform will move for a distance of 0.1 meter, while this boy is standing on the platform and he's throwing the ball in this direction. Okay, he's throwing the ball in this direction. Because of this, the surface is smooth here. The platform stop moving because of the law of conservation of momentum. What momentum this boy has gained by throwing this ball at an angle of 45 degree, that will be transferred to the platform. So the platform will be moving the opposite direction, and it will cover a distance of 0.1 meter. And also this platform will move with the velocity of 1 by 10 root 2 meter per second. It will move for how much time? 0.2 second. So when it is moving for 0.2 second, it will cover a distance of 0.1 meter. Okay, that's the solution for this particular problem. The next problem.